Welcome back. In this video, I'll be solving Leetcode problem 146 LRU cache. So we have to design LRU cache, and we need of one average time complexity for get and put. So nothing crazy. When we get, we also update least recently used structure, which will be double linked list. And when we put, we just have to evict if there are too many keys and update what we have. So let's get to it. I wouldn't say this is easy or even medium. I would say this is a bit hard, at least in my opinion. So if it's not coming to you, well, there are a lot of tricks in the book that you can use. So I'll use key value. And self dot key is equal key, self dot value is equal value, self dot next. I won't use next. I'll use this. Non self dot previous is equal none. Okay, this is the basis of my logic. It's doubly linked list. So first, what I'm going to build is key to node, which will be a dictionary that will store key and connection to the node. So we can use that. I'll use capacity, which is equal to capacity. I'll also use head, which is node. And since keys, well, I'll put 0, 0 because this node will not be in the key to node. Same goes for the tail. Why am I doing this way? Because it will make much easier to track. I will not need to update head and tail, essentially. That's the reason. The literal head and tail, only their previous is or next. For the head next and for the tail previous. And they are always here. So head next is tail, self dot tail previous is equal self dot head. So we have head tail, we have key to node, we have capacity. I think we're mostly done. And now we need two things. We need remove node. So remove, I'll call it nodes to be more clear. Well, I will get remove node with a key. Let's put it that way. When I want to remove node with a key, I'll take node, which is equal self dot key to node of key. I will delete it, so it's self dot key to node dot or I think pop node key. I'll take the node, I'll pop it from the key to node, and I will say node dot previous dot next is equal node dot next, and node dot next dot previous is node dot previous. So I removed it from the key to node and I removed connection. So remove node is totally clear. Add tail. Well, edit tail, I can do whole node. So I will look at it as if it is deleted. So I have to do self.key to node of node.key is equal node. And when I add to tail, I have to update. So self.tail.previous.next is equal node. That's connection from the previous to this one. Node.previous is now this. So the connection between the before, what was before tail, and this new before tail is done. So self tail previous next is node, and node previous is self tail previous. Okay, now I have to do node next is self dot tail. So that's the front connection, and self.tail.previous is equal to node. So something like this. Okay, now let's see get. So if I get, I return the value of the key, otherwise -1. So if key in self key to node, if key exists in key to node, well, then I have to remove it. Then I have to take the value. Value is, I'll build it again, just to make it, just to be sure. So self key to node of key dot value. So that's value. For sure, I will remove node. And I have to do self dot remove node. So I remove node with the key, and I fix the connections. And now I build a new node, which is node with, I should have updated it here, but never mind. Let's just stick with it. So, excuse me, I build a new node with a key value, and I add it to the tail. Add cell and add. I'm not sure I need self there. We'll see. Maybe that's so self added tail node, and this will fix all the connections regarding it, and I should return node.value here. So one step possibly too much, but never mind. I like it like this. Let's first make it run and then possibly can optimize. So getting is okay, but putting is now interesting part. So when we put a node, we have to check if it exists, then we update. So okay, let's do this. So if key in self.key to node, if key exists, then I want to remove node with a key. So self remove node with a key if key exists. Then I want to build a new node, which is node with key value. Well, this is either way. So either way, I'm going to do this. So I'll build a new node if key and self key to node, I remove node. If it's not, then I need to check if self.capacity is equal 0, because if it is, else self.capacity minus equal 1. So this is the story. If it's 0, then I have to do self.remove. So remove node self.head.next.key. That node I want to remove. And when I remove, I take the node, I remove it, and I add connections. Okay, that seems clear. So if capacity is 0, self-remove node. First remove node, if not just do the capacity, and I just want to add to tail this new node then. Yeah, so self.add to tail node, and I think this is it. Add tail. Added them, but they were given. What do you mean to? Okay, this is node object. And what do you mean? Takes one position argument and two were given. What do you mean? Oh, node of type node. Maybe I need to use self. Yeah. I'm really bad with this. So each, but I'm not sure about that. Let me submit and just see if it's working. I'm not like, maybe, well, I'll take a look at it, but why do I really need self? Maybe I'll take a look at it. But essentially, okay, you really have to be careful with this one because there is a lot of room for mistakes. Let's just update. So get. There was, when I used get, I think there was no need to kill the to build a new node. So if key node value, I take the value, self remove node key. Well, it's cleaner, I would say. Yeah, it's clean. Let's keep it this way. I don't wanna. This works, so let's not mess something that's not broken. Okay. Let's see, time complexity, space complexity. So capacity is space. Yeah, of capacity. Time complexity, oh, I don't know, of 1 for the functions, I guess. Yeah, capacity. Okay, this wasn't easy. Wasn't even immediate. I would say this is hard because I made it work this time, but I know I had a lot of issues with this one. So yeah, practice, be clean, be clear, and that's it. Yeah, I appreciate you for following this one, and have a nice day, and see you in another video.